A research poll included 1777 randomly selected adults who were asked whether global warming is a problem. Results showed that 953 of those surveyed indicated that immediate action is required. A news reporter wants to determine whether these survey results constitute strong evidence that the majority, more than 50%, of people believe that immediate action is required. What's the best estimate of the proportion of adults who believe that immediate action is required? So the point estimate, the best estimate is how many answered that action is required out of the total. So 953 divided by 1777. Okay. 953 divided by 1777.536. Construct a 95% confidence interval. So 953 out of 1777 and 95%. 953. So stats, proportion stats, one sample summary. 953 out of 1777 and 95% confidence. So 0.513 to 0.559. Is there strong evidence supporting the claim that majority is in favor? So you look at the confidence interval, all the values in this interval, the ones ranging from 0.513 to 0.559, they are all bigger than 0.5 or 50%. So all these values are making majority values, and therefore there is evidence. So now if this interval had some values which are less than 0.5, then we can't say that there is strong evidence because some values are less than the majority. But here, all the values are majority. So yes, there is evidence. Not because the sample proportion is greater than 0.5, but because the range of values in the confidence interval are greater than 0.5. Sample proportion doesn't make a definitive statement about the population. It's the confidence interval that makes the population statement. A university dean is interested in determining the proportion of students who receive some sort of financial aid. Rather than examine records of all students, the dean randomly selects 200 students and finds that 118 of them are receiving financial aid. Use a 90% confidence interval to estimate the true proportion of students. So what they are doing here is look at the answer choices. They are in terms of this plus minus quantity. And this plus minus quantity is the margin of error. So one thing which you have to know is the margin of error. And then this common value of 0.59, that is the sample proportion. So the sample proportion is obtained by doing 118 divided by 200. So if you do 118 divided by 200, you do get the 0.59. So what that means is that what you really want to calculate is the margin of error. So let's do it on StatCrunch. Remember, this slightly different command for the margin of errors, 118 out of 200 and 90%. So if you remember, to do margin of error, what you do is you do stats, proportion stats, that's still the same, one sample, that's still the same. But now at this point, instead of with data or with summary, you do width and sample size. That's what you will use when you have to calculate the margin of error, or sometimes you will have to calculate sample size. Even in that case, you will be using this one. So you wanted 95% interval, and target proportion was 0.59. Remember, it was the 118 out of 200. And the sample size was 200. Okay, let's see, was it 95 or 90? Okay, it was 90% confidence interval. The target proportion 0.59. So 90% interval. Change it to 90. And now compute the width. So we need, remember, we need the margin of error, and margin of error is half of the width, remember? So width is 0.1144, divide that by 2. So 0.1144 divided by 2 would be 0.0572. If you divide this by 2, it's 0.0572. So that means margin of error is 0.0572. 0.057. This one has the correct margin of error.